This is problem 10.1.7. So they want you to, first of all, to determine the null and the alternative hypotheses. This is set in concrete. It never changes. For a correlation coefficient, remember, rho is the population parameter for the correlation coefficient, and R is the sample correlation coefficient. It's the statistic which represents or estimates rho. And the way we set these up, rho in the null is always equal to 0. In other words, we're assuming there is no correlation, and we need proof otherwise. So what happens is you set up the critical values form the middle around 0. And if you get far enough away from 0 either side, now you're in the tails, and now you have significant correlation. And so that's how you reject the null, that there is no correlation. So what's the test statistic? For R is given right there to 4 decimal places. It's a variance or correlation matrix. It's symmetrical because the correlation between paper and glass, it's identical either direction. And of course, paper with itself and glass with itself is perfect. So that's why there's the ones. So 103.103. Okay, now they're going to ask us for the critical value. So we open up the table, and it says that N is 62. There's 62 households. So the closest I can get is 60, so I round it off. And if it's 5% on the significance level, alpha is 0.05, so it's the middle column. I just go to 60, so 0.254, and it's symmetrical, so it's plus or minus 0.254. Okay, now we are obviously less than 0.254. We're less than or equal to 0.103 is less than or equal to 0.254. Therefore, there's not sufficient evidence because we're in the middle. We can't reject the null. Okay, so that's 10.1.7. And Dr. K, over and out.